Alright, let's talk about high pressure liquid chromatography, or HPLC. So this is where you're going to do a liquid phase, where you're going to have a liquid phase and a stationary phase. So basically you are going to have a mixture of your sample and a bunch of solvent, and it's going to flow into a packed column, so not an open tubular column, but a packed column at very high pressure, up to 1,000 bar, or up to almost 1,000 times atmospheric pressure. And then the way that you're going to detect what you have at different times in your solvent depends on what you're looking for. One common HPLC detector is UV, so basically using the UV part of a UV-Vis spectrometer. So you might do a deuterium arc lamp and a photodiode array, and passing through the effluent of what's coming out of the column. You can also use a mass spec that's usually called LCMS. And there's actually lots of ways to detect things, whatever solute you're looking for. But what's important to know is that you're going to select your solvents that you're going to mix with your sample and push through at high pressures. You're going to select your column and your detector based on what you're trying to measure. So all of that is part of method development when you're trying to figure out how to use it, or how to measure something with a HPLC. Alright, so there's a couple things. If you want increased separation efficiency or increased resolution, you're going to want to increase the rate of solute equilibration with the stationary phase. And so in order to do this, we can't just have a column that's 100 meters long like you do in GCMS, and you can't just make it skinnier. So the way that what we can do instead is to decrease the solid particle, the size of the particles in the solid phase or the stationary phase. And that decreases pore diameter as a result, because you can pack grains of sand much closer together than you can pack golf balls, and you increase your surface area as well. And you can also increase your pressure. Those are the two ways to do that. So let's talk briefly about column. Your column obviously is going to depend on your application. Usually you start with a microporous silica, and there are some really cool SEM images of these microporous silica beads. And then you can derivatize this SiO2 and bond it with organics or whatever. One of the most common HPLC columns is called the C18 column, which has octadecyl whatever. It's a chain of 18 carbons off the end of that gets stuck onto this SiO2. Your solvent also depends on your solute. And you can actually do a couple of different things here. You can do an isocratic elution, where you only use one solvent and you just flow that through as a function of time and see what comes out. You can also do a gradient elution, where you have a continuously changing mixture of 2 or 3 different solvents. And that just depends on whatever method you use. And lots of people spend their whole life trying to figure out how to make better separations methods, and but really at this level, what you can do is just, I want to measure methanol, I'm going to go get a method to do that. Or I want to measure methanol, or I want to measure nicotine, or whatever, and you just go find a method for doing that. I want to measure caffeine in coffee. You just go find a method for how to measure caffeine in coffee. And it just tells you, and then that's super easy. Alright, that's all.